Hello children. In today's lecture we are going to observe how strong a particular acid or base is it. So how to test the acidity of that particular acid or the basic nature of a particular base, how strong it is, how to measure, so how to scale on that one. These things we are going to discuss in today's lecture. So to measure this we have pH. So what is pH? So pH is a potential of hydrogen. pH indicates potential of hydrogen. Potential of hydrogen. So this is a this pH scale is very helpful in identifying the acidic or basic nature and the concentration of the acidic and basic natures of acids and bases. So what is this potential hydrogen and how it is going to measure the acidity or basicity of a solution? So it is based on the concentration of the hydrogen ions in a solution. So it will test the concentration of the H plus ions in a solution. So basically this pH scale is from 0 to 14. The complete scale is from 0 to 14. If the pH value is less than 7, so it is acidic in nature. Okay, higher H plus concentration, and if pH is equal to 7, it is neutral. Example, pure water. So there is equal amount of H plus and OH minus in this condition. pH is equal to 7. If pH is greater than 7, then it is basic or alkaline in nature. Basic or alkaline. So here higher concentration of the OH minus ions in this condition. So the formula for the pH value is, we can use this formula, pH is equal to minus logarithm of H plus ions. This is the formula that will be used in calculation of the pH values. Okay, lower pH means a higher concentration of the hydrogen ions because it is negative here, so making the solution more acidic. Similarly, higher pH means a lower concentration of the hydrogen ions, making the solution more basic. So here I would like to give you some examples for you. HCl, lemon juice, vinegar, pure water. If you test these things, blood, okay, and baking soda. If you observe all these materials, ammonium solution, some examples I am going to give you. Ammonium solution and NaOH, sodium hydroxide. If I test these using the pH scale, HCl is acidic in nature. It is a strong acid. You can observe pH value as 1. And for lemon juice, it is 2.5. You all know that lemon is an acid, right? For vinegar, it is 3. So it is, compared to lemon juice and HCl, it is a mild acid. Okay. And pure water is, just now we told, it is 7, neutral in nature. Blood pH value is 7.4, and baking soda pH value is 9.4, and ammonium solution pH value is 11, and sodium hydroxide pH value is 13. So here you can observe how, if you observe less than 7, all these are acidic in nature. Okay. Greater than 7, all these are basic in nature, and pure water is a neutral substance. It is not neither acidic nor base. So here I would like to mention some more things. Importance of pH, you have to know about this one. In biology, if you consider in biology, so if human blood pH is around 7.4, yes, you know that. So if there is a deviation in this pH value, so doctors will identify that there is a some health issue is there to that particular patient. So depending upon the pH value of the blood, they can identify these things. So if you come to agriculture, if soil pH value is tested by the scientists, okay, and this pH value plays important role in the plant growth. For example, acidic soil is there. So how to overcome that problem? So in that case, you need lime. CaCO3 is used to neutralize the acidic nature of that particular soil. Coming to industry. So pH is crucial in the food also. So pharmaceuticals and chemical process, everywhere this pH value will be measured. So in daily life also, if you observe our toothache, when you get, how you are getting the toothache. For example, if your pH drops below 5.5 due to the acidic producing the bacteria, this is getting you will get the tooth decay also. So whenever you are brushing your teeth, that paste is basic in nature, and that helps to neutralize that acidic behavior in our teeth, and that helps us a lot. Okay, so here I would like to mention about the universal indicator. Here also in your textbook it is mentioned about universal indicator. What is this? So universal indicator is a mixture of several indicators. Several indicators are mixed to form universal indicators. So that shows different colors at different pH values. So this color variations will be there. Different color combinations you can observe using a universal indicator with different pH values. So it helps to determine the approximate pH value of a solution based upon the color change. Depending upon the color codes, you can identify, you can guess the value of the pH. So how it will work? When added to a solution, the indicator reacts with the hydrogen ions, H plus ions in that particular solution, or hydroxide ions present in that solution, okay, and changes the color according to the pH level. For example, if the pH is 0 to 3, then the color will be red. Then you have to identify it is a strong acid. Okay, and coming to, if it is 4 to 6, pH value is 4 to 6, then orange or yellow color you can observe, orange or yellow. So it is a weak acid. As you already know, if it is less than 7, it is acid. If it is nearer to 0, it is a strong acid. It is above 3 and less than 7, it is a weak acid. Okay, if it is 7, you can find green color to that solution. It is neutral in nature. Like that you can identify. For example, it is 8 to 10, you can observe blue color by that universal indicator, and you have to say it is a weak base, is it not? And if it is 11 to 14, you can find violet or purple color, purple or violet color, and you have to identify it is a strong base. Like that, this universal indicator will help us to find out which type of solution it is with, whether it is a strong acid, weak acid, or a neutral solution, or it is a strong base or a weak base, depending upon the colors. So we have the color combinations. For it is a strong acid, red color. For a weak acid, orange or yellow color. For a if it is a green color, you have to identify it is a neutral, example water. If it is in blue color, you have to say it is a weak base. If it is in the purple color or a violet color, you have to say it is a strong base. So in this picture you can see clearly it is mentioned. So increase in the H plus concentration, 7 is the neutral value. So OH decrease in the H plus concentration, okay, and it is basic in nature. 14 is the upper limit and 0 is the lower limit. Variation of the pH with the change in concentration of H plus and OH aqueous ions. So here you can find an activity. Test the pH values of solutions given in the table. Okay, record your observations. So this table will help us to identify acids, bases and neutral solutions, right? So the materials we are using is pH paper, universal indicator we are taking, and various solutions we are having, and we are showing a color chart. Okay, so we will dip that paper into the solution, right, and we observe the color changes, and we will fill this table. Okay, first one, saliva before meal they are asking. So if you observe that, you will find greenish yellow color. So it will be greenish yellow. Okay, and your pH, approximate pH value will be around 7.4. So you have to say it is greater than 7. So it is slightly basic in nature. Coming to the saliva after meal, so it will be completely yellow in color, and 6.5 is your pH value. So it is slightly acidic, because after our meal, whatever the food components, they will be aligned under the teeth, and you will find a little bit of acidic nature, which causes the tooth decay also, that you have to observe. Coming to the lemon juice, you all know that it is acid, right? So you can find orange, red color, right? And the pH value is around 2, and you have to say it is strong acid. Okay, colorless acid aerated drink. So it is, if you dip it, you can find orange color. Okay, and it is around 3.4, and again it is acidic in nature. 3 to 4 you can see. And coming to carrot juice, you will find yellow green color. Okay, and 5 to 6 pH value is around 5 to 6. So it is slightly acidic. You have to say it is slightly acidic in nature. Coming to coffee, you will find yellow color. If you dip it, you will find yellow color. Okay, so approximately 5 is your pH value, slightly acidic in nature. Okay, coming to tomato juice, so if you dip, you can find orange or yellow, slight orange yellowish color you will find. Okay, and your pH value is 4 to 4.5. you can observe around 4.5, and you all know basically tomato is acidic in nature. Okay, tap water, green color you will find, complete 7 is the pH value. It is a neutral in nature. Okay, 1 NaOH, sodium hydroxide. So it is, you will find dark blue color when you dip it. So pH value is between 13 to 14. So it is a strong base. Okay, and 1 HCl hydrochloric acid, complete red color you will observe here. So here the pH value is 1. You have to say it is a strong acid. Like that you will identify the type of material. So if it is acidic solution, like lemon juice, coffee and tomato juice, turn pH paper red, orange or yellow. You can see the colors also down. So if it is red, pure red, it is a strong acid. So it is little bit orange yellowish. So as it is nearer to this 7, you can find a mild greenish yellow color here. So if it is completely green, you have to say it is neutral in nature. And is completely blue, it is strong base. Okay, you have to say violet color, those things, it is blue color. Okay, greenish blue color, it is a mild base. Like that, depending upon the color codes, we can identify the acidic and basic nature of the substances. So our body fluids can change their pH depending upon the food intake that we take. So applications, if you observe, doctors check the saliva pH for the health conditions. Okay, and farmers test the soil pH, choose the right fertilizers for this soil, and industries maintain pH levels in food, cosmetics and medicine. So this pH is having a wide number of applications in all the areas. Thank you.